Hi, welcome to Herzing University IS112 Computer Networks. We are in week 7 and we're going to look over troubleshooting network problems. During this presentation we'll examine how to troubleshoot network problems. Such things as describe the steps involved in an effective troubleshooting methodology, some purpose, some plan. Follow a systematic troubleshooting process, document the symptoms and solutions and results, and use a variety of software and hardware tools to diagnose problems. Good troubleshooting skills are a must in the technology field. You need to identify the afflicted area. For example, a user could call in a state that the network is down. And upon further review, the network is not down, but one program on that user's computer is malfunctioning. Many times I refer to the identification step to the problem solving is the isolation step. Step 2 deals with the identification of symptoms and potential causes. The cartoon on the slides illustrates that many times something has changed on a network device. In this humorous example, a user has removed some parts. Sometimes a network device failure is the obvious. The network wire is broken or unplugged. Step 2 is more of a brainstorming step to list all potential causes. But don't overlook the statement when someone says, "No, I haven't changed anything," because something might have changed that they didn't even know they were changing. Don't forget the simple. Step 3 deals with identifying the most probable cause. Sometimes users do not want to tell the truth for unknown reasons. For example, they may have installed some software that interferes with their network connection on their computer. A key to this step is to make sure that you can recreate the problem. Okay, so step 3, select the most probable cause, verify user competency, recreate problem, verify physical integrity of network connection, verify logical integrity of network connection. If you can test, and if the same problem is recreated, you're in good shape because you can now consistently create the problem. Intermittent problems are more difficult to troubleshoot. Step 4, before troubleshooting a problem, you need to test the result of your solution before implementing your solution. This ensures that the fewest number of users are affected. If your solution does not work, you need to further troubleshoot the problem. Okay. I knew a system admin that used to say, if it works, it's production, otherwise it is a test. That is not the right way to do things. You need to test it. Before proper planning normally produces good results. The same is true with the troubleshooting network problems. For step 5, you need to plan your action to solve the problem. For example, if you uncover one network switch that has one bad network port, you plan and schedule downtime. On the other hand, poor planning would be to remove and replace the switch without any notification to the users. This is like what's on the slide here, using dynamite, drastic explosives. This would explode the problem from one user having a problem to many users having a problem. Step 6. Documentation is a very important part of network troubleshooting. Each problem with the appropriate solution needs to be documented so that you can more efficiently troubleshoot this type of problem in the future, because problems do repeat. You should avoid reinventing the wheel when it comes to troubleshooting problems. Documentation is a great way to improve your productivity. And on this slide it shows you should document everything and include screenshots, which are a good example right here. Future network planning involves implementing proactive technology that informs the network administrator problems before they occur. The example on this slide shows UPS electrical equipment that notifies staff of heat or power problems to a network closet. On an annual basis, the network should be reviewed for upgrades and more efficient network designs. Okay, so you have using technology to monitor your network, because you can't be everywhere. Some other troubleshooting tools: a crossover cable. This cable transmits and receives pairs in one connector are reversed. You can directly connect two devices together with a crossover cable without using a switch or hub. A crossover cable is great for troubleshooting network card problems. Another troubleshooting tool that is great is a cable continuity tester. It's great for testing copper network cabling. In one end of the cabling connect the base unit, which is right here, and then on the other end connect the remote unit. So the cable goes between these two, and the tester will determine if the wiring is good. A network packet analyzer. A network packet analyzer will try to capture network packets and display that packet data as detailed as possible. Well, what you can do with this is use to ensure that what's going on inside a network cable, just like a voltmeter is used by the electrician to examine what's going on inside an electric cable, but this is at a higher level, of course. This example here is Wireshark, which we're going over in this class. Shows all the activity going to and from this device, or this PC in this case. Network monitoring. Network monitoring tools perform the following functions: continuously monitor network traffic on a segment, capture network data transmitted on a segment, capture frames sent to or from a specific node, reproduce network conditions by transmitting selected amounts and type of data, generate statistics about network activity. They also can be used to send out emails to your IT department when a switch goes down, or send out emails when the traffic's too high. In many areas, home users have wireless access that is unsecured. A wireless access point monitor will show all wireless access points that are within range. The key is to secure your wireless access points. In summary, the key to troubleshooting network problems is to use a step-by-step process. Over time, this process becomes natural to a seasoned network administrator. A lot of troubleshooting is basically asking another person to work with you to help solve the problem. It's usually not just one person, it's multiple people. Do not forget the obvious solutions, example, lack of power, unplugged network wire, etc., or a broken network wire. A well-run network annually upgrades their equipment to improve the reliability of their network. Finally, there are many network troubleshooting tools available that make sure you spend the time. Make sure you spend the time understanding them, how to use them appropriately. As always, let's remember to try and apply what we've learned outside this class.